The lesson outcome for this video is, I can determine parts of polynomials. First of all, let's discuss what a polynomial is. The definition here will be on a later screen, so you don't need to write that down right now. But a polynomial can be expressed in terms that have only positive integer exponents and have the operations of addition, subtraction, and multiplication. So there cannot be any division in a polynomial. Also notice there will always be addition or subtraction in between a set of terms, and again these terms have positive integer exponents. Now, let's take a look at this polynomial. First of all, this is how you would read it. 3x to the fifth plus 2x to the fourth minus 7x squared plus 9x minus 4. One of the things we need to understand about polynomials is how many terms there are. In this polynomial, there are 5 terms. 1, 2, 3, 4, 5. The 5 terms are divided up by addition or subtraction. Another thing we want to know about polynomials is their degree. The degree has to do with this number right here, the highest exponent, or the largest exponent on a variable. In this case, 5 is our highest exponent on our variable x to the fifth, x to the fourth, x to the second. This would be x to the first. There are no x's here. We'll talk about that in a second. So therefore, this is our degree. This is a degree 5 polynomial, or 5th degree polynomial. Another thing we need to talk about is the very first number that belongs with that variable with the exponent that's the highest. So the degree, the one that shows us the degree. We need to know about the number in front of it. That is what we call the leading coefficient. Now the leading coefficient, leading because it's the front, and a coefficient is always the number in front of a variable. So it's our leading coefficient, and it's going to be an important thing that we discuss during different sections of this course. In this case, the leading coefficient is 3, and like I said before, the degree is 5. Another thing we'd like to make sure you understand is that the very last term, I told you I'd come back and talk about it, the very last term that's listed, if it does not have a variable, okay, so there is no x right here. If it has no variable, it is what we call the constant. And it is a constant because, well, it's a constant number that doesn't change based on what x is, because there is no x with that negative 4. The sign that's in front of it is important. If this is a plus, it's positive 4, but this is a negative, so our constant is negative 4. Okay, so the degree is 5, the leading coefficient is 3, and our constant is negative 4. And like I mentioned at the beginning, if we have a degree 5, this would be called a 5th degree polynomial. Now one thing you do need to be careful of, as I noted down here, be careful when the polynomial is not written in what we call standard form. Standard form is the way we write it when the exponents decrease from left to right. The exponents on our variables decrease from left to right. So you'll see the 5 here, the 4 here. We don't have 1 with a 3 in this example, and that's fine. We have a 2 here, x to the second. We have a 1, x to the first power. And this is technically x to the 0 power, as we've talked about the 0 power. And so therefore, our exponents do decrease from left to right, which means it's in standard form. When it's in standard form, we know this first term will help determine our degree and our leading coefficient. Okay, so on this screen, I have listed 5 different polynomials. We can determine that they're all polynomials because they don't have any fractions in a term. So for example, the 7x isn't 7x over y or anything like that. We also don't have any negative exponents. They're all positive values of exponents on our variables. And so therefore we have polynomials, and let's also take a look and see if they're all in standard form as we discussed on the previous page. So this is x to the second power, this is x to the first power, so this is in standard form because the numbers are decreasing from left to right. the exponent numbers. This is a to the third, a to the second, and a to the first. So that also is standard form. This is m to the second. This would be m to the first. That is in standard form. This is x to the first power. This would technically be x to the 0 power, and there's no x's here, so that's fine. It's in standard form. And this number 5 is actually just fine as well. So go ahead, pause the video, and see if you can list the degree, the leading coefficient, that's my abbreviation here, the leading coefficient, and the constant for each of these polynomials. Then restart the video to see how you did. Okay, so the degree of our first, the red polynomial here, the degree is 2. Okay, it's a degree 2 because the leading term has an exponent of 2. The leading coefficient is right here, and there's not a number there. Remember, when there's not a number there, the number is 1. So our leading coefficient is 1. Our constant is the number that doesn't have a variable part, and that's right here, -3. The next example, the degree is 3. Our leading coefficient is 4. And our constant is actually 0. Our constant is 0 because there is not a number listed in this polynomial that doesn't have a variable. There is no term without a variable. Notice this one here was a term with no variable. This is a variable, so therefore our constant is 0. The degree of the next one is 2, the highest exponent. The leading coefficient is again 1, the number out front of m. And again, our constant is 0. The next example, the degree is 1. Remember, there's a 1. When an x, a variable, does not have an exponent, the exponent is 1. So our degree is 1. It's a first degree polynomial. Our leading coefficient is 3. And our constant is -2. That number right there. And the 5. The degree is 0. There is no degree, because again, what you can think of, and I'm going to erase this after I write it, but you can think of this being x to the 0 power, because we know anything raised to the 0 power is 1. So technically, that isn't there. It doesn't need to be written, but it still tells us that the degree is 0. The leading coefficient doesn't exist because there's no variable to have that leading coefficient on, so that doesn't exist. And our constant is 5. Like I said at the beginning of the video, I was going to show this definition here, this definition here again, and if you want to write this definition down, you can, or if you just want to reread it and be aware of what it's saying. So again, a polynomial can be expressed in terms that we add or subtract, and multiplication can be used as well. They only have positive integer exponents. Okay, the exponents can only be positive and whole numbers. And again, we cannot write the expression with division. So let's take a look at these 3 that are polynomials. If you notice here, okay, 2x squared plus 6x minus 9 is just fine. There's our leading coefficient, 2. Our degree is 2 as well. Our constant is -9. This is degree 3. -1 is our leading coefficient, and 9 is our constant. And in this case, again, it's written in standard form. 4th degree, degree 4. The leading coefficient is also 4, and our constant is 24. Over here are not polynomials. This one right here is not a polynomial because x is being raised to the -1. Remember, if there's a negative exponent, you're going to move that factor to the bottom and make the power positive. So now we will have a fraction, and we do not have fractions in polynomials. This is not a polynomial either because the square root of x is actually another name for x to the 1/2 power. We cannot have a 1/2 as an exponent, and therefore anytime you see a square root around an x, it also shows you it's not a polynomial. And the last one, the x in the denominator means we have division, and we can't have a variable in the denominator for a polynomial. Again, the -1, the square root, and the x in the denominator tell you that these are not polynomials. And that is it so far for our introduction to polynomials. We'll do some practice in class, and we'll learn a lot more about them in future lessons.